We're still seeing chicanes being put on cycle route entrances, with designers believing they're improving safety and usability of the route. So we've made this video to show why chicanes are a big problem for accessibility and safety, and to help people understand why the National Cycle Infrastructure Design Guide, LTM 120, says chicanes should not be used. Here's a chicane design we've recently seen described as meeting LTM 120 standards. It's drawn to scale with a bird's eye view. Each little grid square is 20 centimetres across. Here's the cycle path with a gravelly semi-bound surface, then asphalt at the path junction. Here's the pavement, which is cycle permitted in some of the designs. Here's the road carriageway, and here's the route fencing. Here's where the pavement will slope to give a dropped curb. I've used typical dimensions here as the dimensions weren't shown on the design drawings. The gradients and increasing curb step heights at the sides of drop curbs are important as they make the red areas unusable for many people using cycles, wheelchairs, mobility scooters, rollers, crutches and more mobility aids. Here are the possible approach directions for people walking, wheeling and cycling. Here are the approach directions for drivers. And here are the chicane barriers. As you can see, the chicane has 1.5 metre gaps between the chicane barriers and fences and 3.5 metres between the barriers. As a baseline, LTN 120 requires 1.5 metre space through access restrictions with straight line approaches. The straight line approaches are really important. And we're assuming that this whole area is flat because once we're taking slopes into account, this space becomes massively worse for accessibility. People using multi-wheeled mobility aids risk tipping over if they have to go across slopes, and starting uphill while turning is impossible for many disabled cyclists. So when we're looking at cycling infrastructure, the absolute minimum that's allowed is that the cycle design vehicle can physically get through and that sight lines and spaces around any barrier makes the area safe to use. Here's the cycle design vehicle. The cycle design vehicle is 1.2 metres wide, 2.8 metres long and has a 4 metre external turning radius. It isn't a real cycle. It's the width of a side-by-side tandem, the length of a single bike with a child trailer attached and the turning circle of a tandem bike or similar. A tandem towing a child trailer is longer than this and some cargo bikes are longer too. So can the cycle design vehicle use the route? We can put the turning circles onto the route and see what happens. There are proper swept path analysis tools to do this more elegantly, but I don't have those, so these are based on 4 metre external radius curves, 1.5 metres wide for that minimum access gap. Here's crossing to and from the track opposite. The red circles show where the cycle design vehicle collides with obstacles it can't pass. Here's using the road from either direction, and here's using the pavement from either direction. We can see that if the rider is very skilled and accurate, and as long as the drop curbs are ignored, maybe clipping the fence, the cyclist can possibly just about make it onto and off the track from the road or from the track opposite, but they can't turn on and off the pavement, even if that's a cycle track too. It's not reasonable to assume that cyclists will be riding to millimetre precision or to limit the directions people using larger cycles are allowed to turn. So we've established this design is inadequate even if there's just one highly skilled rider using the space and the space is maintained to perfection. But what will happen in reality? Well, the space won't stay perfectly maintained for starters. Debris will build up in and around the chicane barriers. There will be debris on other parts of the track too, but generally less because the flows of path users across the space will help keep the route clear. Debris on the rest of the route matters less too because over half the width isn't already blocked by metal barriers. One dog poo, broken bottle, cast aside stick or horse poo will make the chicane completely inaccessible or incredibly unpleasant and hazardous to use for many disabled people. Every person going across the track is going to move over this patch of ground where the semi-bound surface meets the bound asphalt surface. The semi-bound surface will wear away, quickly forming a step that will be hard for disabled people to cross. Then a pothole, which will make getting on and off the route difficult and unpleasant for everyone, especially in wet weather. Vegetation will grow up behind the fences. It's very difficult to cut vegetation behind fences, especially with chicane barriers in place. Routine maintenance will probably be done by machines cutting in front of the fences and will probably be less effective in the area around the barriers. Brambles can grow over 2 metres in a year. Nettles, thistles and so on will grow over 1 metre. Even common hedging plants like privet can grow over half a metre. Plant growth will reduce the usable chicane widths and is likely to make the space inaccessible for parts of the year for users of wider cycles and other mobility aids. And generally the time the route will be obstructed will be summer and autumn, when most people will want to use the route. We need to remember that people using aids like mobility scooters, canes, wheelchairs and hand cycling cannot use their hands to push vegetation aside while moving or twist sideways to avoid branches. Blind and visually impaired people often won't be able to detect bramble, canes and nettles. Many other people using any kind of cycle or pushchair will be affected too. And of course the fences and vegetation block sight lines between the path and the pavement, increasing risk of collisions. A bit more about these fences and chicane barriers. The fences and barriers are designed with horizontal rails, perfect for sitting on if you're in need of somewhere quiet to hang out. So children and teens are likely to use the space around the chicane barriers. They'll probably be really nice people, but no matter how lovely they are, they're going to make that space unusably intimidating for some people, especially because the chicane barriers can be used to help block people into the space, increasing odds of harassment, abuse and assault by anyone waiting in the area. And now let's think about who's supposed to be using the route, which is meant to be an active travel corridor including to a number of schools. We'll assume the route's in a reasonably well maintained condition. And what happens? So we're going to have people moving in groups. We'll often have a parent, grandparent or carer who may well be riding a cargo cycle, towing a child trailer or using a mobility scooter. There'll be accompanying children who may be on bikes, trikes or other cycle types and may well need verbal or physical help to make a safe start across the road. Can they all get through the chicane and safely over the road? If the adult goes first, no, they block the access, the children can't get to the curb. If the children go first, no, the adult now can't get near enough the carriageway to check if it's safe to cross or to give assistance. What about if one of the children's riding an upright trike? Or if they're coming off the road and a recumbent trike rider is coming the other way? Because of course the intention of building a cycle track is to have lots of people using the space on all kinds of cycles, other mobility aids and walking. The chicane will force people to wait on the carriageway, risking being hit by drivers. It will force users moving in opposite directions into the same small space, so misjudgments, especially by children, teens and inconsiderate adults, are going to cause collisions in and around the chicane space, and intimidation of those path users who are more likely to be seriously hurt in those collisions, older, younger and disabled people. As soon as you start thinking about real movement of real people through the space, it becomes clear that a narrow winding passage at a junction is a really bad idea. Of course, those aren't the only issues. What about riding after dark, at quiet times, in winter, after a storm? Simply putting in a wider chicane won't solve any of the issues we're talking about. In its current design, the chicane won't solve the slow, fast cyclists on standard bikes, e-scooter riders or motorcyclists. A reasonably skilled bike rider could weave through those barriers without slowing just by leaning a little. Any barrier which will stop a motorcyclist or slow a fast bike rider will completely prevent access for many legitimate route users, including many disabled people and families with children, including disabled parents, carers and disabled children. So what can we do instead? Well, quite a lot of things. First thing, use bollards, which give at least two 1.5 metre wide gaps with straight approaches instead of chicane barriers. Only necessary if it's to stop car and van drivers getting onto the route. That's exactly what the National Cycle Design Guidance LTM 120 advises. Lockable bollards allow maintenance and emergency vehicle access. Now you've got two-way flow for all legitimate route users, and less wear on that joint between the semi-bound and sealed surface, so less step and pothole formation. Actually, while we're at it, the semi-bound surface isn't very accessible either. The whole route needs a machine-laid sealed surface if it's going to be usable in the medium to long term by everyone the design is intended to be used by. We can open up the junctions, splay the path mouth as wide as possible. Think about how major roads widen to give more lanes at the junction than the road itself has. And this opens up safer sightlines too. We don't put fences up right to the point where drivers want to turn because it's not safe. We can minimise the fencing, which makes it easier to get vegetation cut well back behind path edges and reduce costs, and it stops the middle of the path being an attractive place to hang out. Sadly, we might now need some extra bollards to stop drivers parking, blocking the entrance. We can make wider, gently sloping drop curbs, or even better, raised carriageway tables that will make moving easier for people walking, wheeling and cycling, and warn drivers they need to slow down and give way to track users. If there's concern about cyclists going too fast through the space, designers could consider using paint or warning signage to encourage people to slow down, which are exactly the same measures used to warn drivers to slow down in most places too. And we can add in some nice benches and a bin in sensible locations. These kinds of accessible solutions can be cheaper than inaccessible barrier-covered access points, and they're safer and easier to maintain. Everyone wins. So that's why chicanes are not accessible infrastructure for cycle routes and some of the alternatives that can be considered. Thanks for watching. For more resources on accessible walking, wheeling and cycling, visit www.wheelsforwellbeing.org.uk.